All right. Afternoon, well, close to afternoon. My name is Bryson Tyrrell. I'm a systems administrator at Jamf Software, formerly Jamf Software, now just Jamf. I work on the Jamf Cloud team, so the team that actually does the automation behind our hosted platform. And today I am here to talk about your code should document itself. And if you're here in this presentation, you probably acknowledge the fact that documentation is important. There is this common adage in our profession that we should probably document that. I'm pretty sure everybody has said that at one point. And it's not that, to me at least, it's not that documentation is hard per se. I find it's less about, I know I should document that, I just don't feel like doing that right now. It's more like, I should document that, but I don't want to jump out of what I'm doing and go into my wiki and go update my documentation there, because that breaks up my flow, and then that makes it, that takes me out of my focus, and it makes me lose productivity. So the approach that I've really taken to all this is really one of documentation as code, where if my documentation is living within the project that I'm working on, then I'm more likely to update it as I'm working, and then whenever I'm done with whatever I'm doing and I commit it, my documentation has been updated. So this is the Mac troll slide, because if you're here, you've read the description, you understand this is a Python-centric presentation because I'm talking about documenting Python projects. I feel like during his presentation yesterday, Joel could have still said something nice about Python. I don't think it would have killed him. I mean, he's got lots of examples out there. He could have mentioned that as of the Stack Overflow survey for 2017, Python has 5 times the presence out there that Swift does. He could have mentioned that. It wouldn't have killed him. So going back to this whole thing about documenting our code, having the documentation be a part of the code, Python has a convention for this. It's called the docstring. And the definition of a docstring, according to PEP 257, is a docstring is a string literal that occurs as the first statement in a module, function, class, or method definition. If you don't know what a PEP is, it's a Python enhancement proposal. These are all proposals that have been made, that have been adopted or rejected, that go to improving Python as a platform. That's a very dry explanation. It's a lot easier to understand it when you actually see it as an example. So here we have a docstring. And as you can see right here, it's the first line right after the definition of a function, and it just tells us what the function does. PEP 257 lays out the conventions for docstrings. They aren't hard laws, but they are practices that you should follow because it ensures consistency across projects. The basic things are you should use triple double quotes at the start and beginning of a docstring. For a one-liner, it should present just like you see on the display here. For a multi-liner, it should start on the same lines as the first triple quote, continue on, and then the last triple quote should be immediately after that. You shouldn't have blank lines at the beginning and the end of it, things of this nature. So as we move on here, I've now added a parameter onto this function. I've expanded the docstring to better describe what it does. It's saying that if a name is provided, it'll print hello name instead of just hello world. For code that becomes more and more complex, and there are more things that it does, and there are conditions that might occur when it executes, you have to really be on top of keeping your docstring up to date. And even this is not entirely clear because Python's not a typed language like Swift. You can optionally type it now, but it doesn't say what name is supposed to be, or if there are any restrictions on what you can pass as name. What we can do is we can actually add some markup to this. And using the markup, we can add some more context around what's accepted, what gets returned, what conditions might occur within this function. This is using markup known as reStructuredText. And right here, on the second line right there, you can see that I've added a keyword called param. I'm saying it's a string for the name. I'm saying this is an optional name that you can pass. And it actually has a return item at the bottom that tells me it returns a string and what the potential values for that string are. just occurred to me that I can't actually see my notes on the presenter screen here. So I'm winging it now. Now, like I said, that markup just there is RestructureText. I'm focusing on how to do documentation using this markup. It would be remiss, though, if I didn't point out that there are alternatives to this. This is a Google-style docstring. Google came up with their own format for doing this that achieves the same results. It just reads differently. And there are ways to leverage this for generating documentation using the tools I'm going to explain. I'm not going to go into them, but I just wanted to put that out there. So, RestructureText. RestructureText is not that dissimilar from Markdown. Like, show of hands here, who has used Markdown before? Out of curiosity, who here has used RestructureText? We have one. Not bad. It's not that far removed. Markdown and RestructureText are very similar. Markdown is very much geared around code documentation, though, whereas Markdown is just a general markup language. So in here, these are just some examples. Then this feels a lot like Markdown. We have italicized text, bold text. Inline code is denoted by double backticks. Indented paragraphs are considered quotes, and then you dedent again in order to move on. So RestructureText actually shares some characteristics with Python where indentation is leveraged all over the place for telling you where things start and end. When this gets rendered, looks just like this. Lists also, very similar to Markdown. Asterisks for bullets. You can hard code the numbers for a numeric list, or you can have a numeric list dynamically generated by just using a hashtag symbol. And then, of course, using indentation, you can nest items within your lists. Headers are divergent. Headers are handled differently in RestructureText per Markdown. Here's the thing about the rules with headers. The characters that you use to define a header are not static. You get to pick what characters you use for which headers, and the way it gets determined is the order that they occur. So these two examples right here will render exactly the same. Because I'm using the equal sign for the header line, that becomes header 1. The second one that occurs in either one of those, on the left is dashes above and below, on the right it's just asterisks below it. Because that's the second occurrence, that just becomes header 2, and so on and so forth. There is a convention for this if you don't want to just wing it on your own. On the right here, this is pulled from the Python docs. This is their recommendation for how to approach headers in RestructureText. These are the characters that they suggest you use and what they map to. And then that all renders like this. Like I said before, those first two examples, they render exactly the same way because of the way that RestructureText handles the order for when it reads in those characters. So, like I said, RestructureText is it was made for doing code documentation, so it actually has a lot of stuff in it for showing code. The most basic example here, if you use 2 colons after a paragraph and then you indent the next section, that section will become formatted as a code block. And it renders just like this. Oh, I typoed hello. Yeah, I did. There is a much more obvious way of doing this because double colons can be not the easiest thing to interpret. And plus, the default in RestructureText when it gets rendered in the toolset that I'm going to talk about is it'll try to render as Python. What you can do is use this code block directive. These things where it's got 2 periods in front of it and then a keyword, these are called directives. And I'm telling it to render this as Python syntax. So it's the same exact thing, but I'm being much more explicit about what it should be doing with the next block of text. So let's go back here and take another look at this updated docstring that I made for this hello world function. So, like I said before, these right here, these are called info fields. So code block, that was a directive. These are called info fields. So param stands in for a parameter, an argument that's being passed to the function. The second piece to that is the type that it is, so that you can include type hinting through your docstrings instead of explicitly. And then the name of that actual argument. And then on the right is a description. This can be broken out so that for readability's sake, you can say you can give them the description and then define the type on 2 different lines. And there are good examples of why you'd want to do this, and I'm going to show you a couple of those a little later on. Down here, this is where we're defining what it returns. In this case, the function returns 2 static strings. It's either hello world or hello name. The type is a string, so that's where that rtype info field comes in. But it might be that your function could return lots of variable sets of data, but they're all of a specific type, and you just need to provide a description for what it is. So it returns the description, rtype is the type. So that could be string, dict, tuple, or some other Python object. So like I got some examples of that right here. When I say that you could return things like lists, dictionary, strings, you can even be more explicit by saying it's going to be a list of integers. It's going to be a dictionary where all the keys are strings and all the values are integers. It could be a tuple that contains nothing but floats. You can even have it return state in your documentation that it returns multiple types of objects. So it could be an integer, or it will return with none. It might return a string or an integer. So it supports the OR operator in order to denote if it returns multiple types. So we're going to look at another example here, and this is out of a project of mine called ODST. It's a distribution server, and this file here is out of the security module, and it's the AES Cipher class. And this one's fully documented. All the methods, the class and all the methods have docstrings, and there's a whole bunch of information that it's actually defining in there. And we're going to take a quick look through this to show off a little bit more about how RestructureText can go into the docstrings. So right here, block size, it's a class attribute. There's a new info field here, adder. This is where you can actually dictate given a description for the attribute for the attribute of that class. And then there's another info field here for raises. So conditions that might occur when something executes, like it might raise an exception, it might throw an error. You can define all of those using raises and then the exception that it will raise, and then a description of why it will raise that exception. And you can define as many of these as you want for all the types of exceptions it might throw. Down here, this is an internal method. It's a method to return a cipher object for when it goes to perform encryption and decryption functions. I'm actually referring to those encrypt and decrypt methods right here. These are separate methods that are in this class, and it's stating here in the description that it returns a cipher object for them. This inline method info field will actually provide a link when this gets rendered later, and you'll get to see that. I'm also referring to the attribute here, so this will also become an inline link later on. Now, down right here, parameter IV. This is a multi-line description. So, like I mentioned before, indentation gets used a lot in RestructureText to denote when things begin and end. So, if you have a line continuing on from an info field, you indent it again to state that this is a continuation of that paragraph. And then down here, under returns, you can see that the rtype is actually this really long path to an object that's a part of the cryptography module that I use in this project. So, your return types can be anything that is an object or a class in Python. So the rtype here in this case is cryptography.hazmat.primitives.ciphers.cipher. That's a class type that returns the cipher object. So this is actually what this returns. This is the example I was talking about where if this was a parameter, for readability's sake, you don't try to do that all in line. You separate it out into 2 lines to denote what it is that you're returning or you're accepting. So I just gave you a RestructureText primer, and I showed you all this markup, and none of this actually looks helpful at all. So it's like, what is the actual end goal of what we're trying to do by injecting all of this into our docstrings as we're doing our code? Well, the end result is actually this becomes this. And it's a much more human-readable format. And it's all rendered from all the markup that we were doing as we were writing our code. This is where we shift to talk about Sphinx. Sphinx is the tool set that generates documentation from your docstrings that are rendered, that are marked up with reStructuredText. But this page right here is just this. So in my project, I have a file for my documentation which points back to that security module I was talking about. And all it is it's just pointing to my class, and it's pointing to some of the private methods there. And then all the actual rendering that you saw on the page is when it pulls all those methods and that class in, and it parses the docstrings. We're going to do a little quick primer on Sphinx here. In order to get started, Sphinx, it's a Python toolchain, so of course it's available within pip, or the Python package index. You install with pip installs Sphinx. Then, inside our project directory, so let's assume that I'm inside the directory where ODST's code lives. Alongside it, I'm going to create a directory called docs, and then I'm going to actually, I missed a step here, I would then move into that docs directory, and then I would run this Sphinx quick start utility. When you install Sphinx through pip, it actually loads 4 command line tools that you're going to use for your projects. The only 2 I'm going to talk about here are Sphinx Quick Start and Sphinx Build. There are 2 others, AutoDoc and Auto API, I believe, but I'm not going to touch on those. I don't actually use them. All right, so now got a little video preview because I did not want to attempt to do a live demo with how poorly I type. So I'm going to create a docs directory in ODST. I'm going to move into that docs directory. Now I'm going to use Sphinx Quick Start in order to generate all the files that are required for the documentation. And this is really just a wizard. Sphinx Quick Start just walks you through a nice, easy-to-use wizard on what you need to do. Root path of the documentation, we want that to be the docs directory. So that period right there in the brackets, that's a default option. When you see those are the defaults. For the most part, I use almost all the defaults. We're just going to accept the things that it wants to use for the default setups here. I'm going to give it name of the project, type in my name as the author, or authors in that case. But then for the version here, I'm not going to enter anything. So when Sphinx builds documentation, it will put the version of your project in there if you code it in. I never hard code the version, and I'll show you what I do because I like having one source of truth when it comes to some of these things. And so there is a way that I approach this that makes sure that the version of my project is always being used every time without me having to go manually update it. Project language, I leave it at the default of English, but of course for whatever country that you're working in and you're publishing your project from, switch over to that language. It's got a link there for all the key values for all the languages that are supported. And then down here, the name suffix for files. .rst is for restructured text files. Again, this whole presentation is about doing all this with reStructuredText. There are alternative ways, but this is the default, and this is how I go about doing all my documentation. So again, the root of it, index is standard. We're going to leave it at that. Note there that it's got an option for an EPUB builder. So what I'm focusing on is HTML-generated documentation, but there are options in here for actually creating EPUBs so that there are alternative ways of distributing the documentation for your projects. And then there's this section at the bottom here. And these are our standard extensions to Sphinx. Sphinx is a tool set, and like most tool sets, it supports extensions and plugins in order to expand the functionality. These are the most common ones that are just included with the installation, and you can flag them on or off optionally. The ones that I've actually turned on for this project are AutoDoc, which is an extension that's going to allow me to pull my docstrings into the documentation and render them. The other one is going to be the to-do plugin, because there's a special directive called ..to-do, where it's a comment that doesn't normally get rendered, but if you want to leave yourself or somebody else who works on the project a note about, hey, this is something that needs to be worked on in the future, that's what you use the to-do field for. And if you turn on this plugin, it'll render it as a special info box whenever it builds documentation. Then the last one I turned on here is coverage. And coverage is a handy little tool so that as you are pointing to parts of your code base, if things aren't rendering, you can actually use this plugin to tell you if you have left things undocumented. And I'll show you an example of that in a little bit. Makefile is a really handy utility for quickly building your documentation. Sphinx build is a tool for building the docs. The make file provides a really easy way of just quickly doing it. I prefer using the make file. There is an optional Windows command if you happen to work with people who are on Windows machines and you want them to be able to build docs. You know, you include the Windows file, but I don't work with any Windows developers, so I don't do that. And then we're done. Now, what this whole wizard has done is it's actually created inside that docs directory all these resources, and these form the basis for the documentation that Sphinx is going to generate for us. So in the repository, in our docs directory, it's created this build directory where I output all the builds of the documentation that it does, static files, so if you were to include images or other resources with your docs, they would go in there and you would reference them. Templates, you can actually create templates for your rendered pages and then use those. I haven't done that myself yet. I haven't found a reason to because I use themes, but that is a really handy tool. Then this configuration file right here, this is where we're going to step into next because we need to go make a few more changes before we're ready for Sphinx to start building our documentation. All the settings that we have been doing up to this point went into there. And then indexrst, that is the default page it creates. That's our root page. And then the make file, which is going to expose some commands for us to be able to easily pump out docs. So, like I said, we need to make a few changes inside the into the conf file. First things first is that these lines are commented near the top of it. In order for Sphinx to import your project, to be able to parse code out of it, it needs to be able to import it in the first place, so it needs to know where it is. So what you're doing here is cystpath insert. This is a handy command where in the Python environment, it'll insert into the system path variable the location of your project. So that way when it goes to run an import to read in your methods or your classes, it's going to be able to do so. So this exists inside the docs directory, so we're telling it insert the parent directory of the docs into the path. Now, what I said before about not hard-coding the version inside this configuration file where I skip that, this is how I do it. I actually use the version dunder. A dunder is any variable inside Python where it starts and ends with 2 underscores. It's for metadata about the file itself or the project. So in the init file for the ODS application is this version identifier. And this is where I go and update the version whenever I'm committing code. So what I want to have happen is every time I do that and Sphinx goes to build documentation, I want it to just import that version and then use that value for these strings here. So that way it's always reflecting whatever I've set the version of the project to. And just to show you, when it goes and generates documentation, the default place where that gets inserted into is the title. But that's for the default theme. In other themes, the version gets used in other places as well. So now that we've made those changes to the configuration file, we're going to move on, and we're going to actually go and make a whole bunch of edits to that indexrst file. And we're going to be making other RST files, and we're going to actually build out the framework of the documentation. Because my approach is that I don't really believe in just having documentation get dumped from your code base and it looks however it does. My approach is that I create the framework of the documentation that's human-friendly, human-readable, and then I have the portions of the code base that provide the docs about how they operate or how they get used loaded into those pages. So this was indexrst. This is a comment that gets added by Sphinx Quick Start every single time you start a new project. So comments just start with 2 periods and then properly indented paragraphs after that, and then they never get rendered. They're just comments. So new directives here. Warning and note. These will produce message boxes in your documents that are colored to call out important information. Scroll down here. Lower in the document, I've now created table of contents entries because I've created more files in here that are within subdirectories. So you can see here under the admin guide, I actually have a folder called admin, and there's 4 different files in there. Those are all RST files. When you want to refer to something, you put the path to it without the extension. So I've given it a caption. The caption will become the title of that table of contents section. The max depth refers to the header levels. So I'm saying I only want things with header level 1 to get rendered in this table of contents tree. And all the files I list directly under this are going to be searched through for all the header 1s, all the headers. And then it'll render out all the header 1 items that are inside those files. If you want to show more things and have an even bigger table of contents tree, you can increase that max depth to like 2 for level 2 H2 headers or H3 headers and so on. But that can create a really long index page if you do that. I prefer just showing the top level headers. Then I got three more sections here. One for an API reference, which has just one file under it. Another one for installation guides, and then a third one for developer-specific docs for other people who are jumping in to work on the project. And this one right here is actually where that security module that we saw, example we saw earlier, this is where that file is. Then a whole bunch more text here, and then we get down to the bottom. This is a lot of stuff that I've written by hand, and that's because this is not important to the code base. This is all information for people who are reading about the project. It all exists within the same repository, so I'm still within my one editor doing all this work, and I'm not jumping back and forth between systems. But this goes back to my personal philosophy, which I see reflected in a lot of other open source projects where you have a lot of your core documentation about the functionality within the code base itself, and then that's wrapped around more human-readable elements, which makes it easier to navigate around. So, building the docs. If we're inside that docs directory in our terminal, we got two options here. Sphinx build. Sphinx build, path to where the docs are, and then path to where it's going to output. The makefile shortcuts this by doing the exact same thing, just you tell it make and then the type of docs you want, and it defaults to it's going to build from the current directory and it's going to output into the build directory whatever type you want to make. So these are actually doing the exact same thing, just that makefile aliases to it. Another thing you might want to do is you might want to make sure that it's not just updating files when it detects changes. You might want it to rebuild the whole thing from scratch every single time. So make clean will clear out everything that's in the build directory, so it won't reuse anything that was there before. And then the -e argument for Sphinx build should do that as well. Now when we do that, this is what we get from that long index page that we just saw. This is how it renders by default. And this is okay. It's really bland though. And this is the default theme that comes with Sphinx. It's called Alabaster. If it looks familiar, that's because Alabaster is based off of the Flask docs theme as well as the request docs theme. It's based off of both of those projects' work, and it comes bundled in with Sphinx. This is what I actually use for the Sphinx documentation. This is a separate theme. So Sphinx actually has a whole bunch of available themes that you can choose from in order to make your documentation a lot more presentable. This is the Read the Docs theme. I like it a lot better because the text is bolder. There's no serif to any of this. It feels easier to read. I like the way it handles populating the sidebar better, and plus there's contrast. So to me, this is a lot more readable right here. If you can see that yellow box and these blue boxes right there, the yellow box is that warning directive that we saw earlier, and the blue boxes are the info directives. So when I'm trying to call out important notes throughout the docs, we can see that they get rendered and they pop out more. So themes, like everything else in the Python tool chains, they're available on the Python package index. You do pip install and the theme that you want. And then inside our conf file, right here, in this line where it says HTML theme, it would say Alabaster by default. You replace it with whatever theme it is you installed with the project. So we installed Sphinx RTD theme, and we switch this line to it. And then if we go rebuild our docs, we will now get this. So in here, I've also done another update where there's multiple sub-modules inside that security module. One of them is for generating cryptographically secure password derivatives, except that there's nothing in here. But when I go look at the file, I can see here I've got the auto module directive in there pointing to that passwords Python file, and my to-do note got rendered right there. But there's nothing being shown for passwords. So the thing is that Sphinx doesn't throw errors if there's nothing for it to actually render when it reads something. So before, I had actually brought in that coverage plugin. To show an example of what the coverage plugin does, you use it with Sphinx build. The -b argument tells you that you want to use a different builder. In this case, coverage is its own build tool. So you pass that. And then sort of the same thing, the directory that you want to do the build from, and then where to output. So we're going to use the coverage, we're going to say build coverage is where we want it to output. And then when we do this, it's going to give us this python.txt file inside that build directory. If we read that, it's saying, hey, there are actually undocumented functions that are inside here. So Sphinx doesn't throw errors if it doesn't find anything to do. By default, if you have undocumented methods, objects, or whatever inside your code, it just won't render them at all. There is a flag that you can set when you're doing these directives called static or undoc members, which means it'll still render them there, but it won't have anything with them. It'll just say that there's a function called derive key, but there's no docstring for it, so there's no description. So if you want to make sure that everything gets rendered, even if it doesn't have a docstring, you can pass that as an option. But this tool is good for doing a spot check to see if you've included functions or code into your docs that actually don't have any descriptions with them. So another really handy thing about Sphinx is that in addition to themes and all this other stuff, it also, like I said, it supports extensions, and it comes with a whole bunch of them by default, but there's even more of them out here. So like this page right here, this is for the admin API. At the top there, we had a table of contents about all the endpoints, and then we have all the endpoints detailed out here with nicely rendered examples of how to make HTTP requests and what the HTTP responses are going to be to those endpoints. That's done using a plugin called the HTTP domain. Domains in Sphinx are collections of directives around certain languages. Sphinx was created originally for the Python.org documentation. So its main thing was that it's for Python. It uses the Python domain. It does support C and JavaScript, but it's always primarily been a Python documentation tool set. This thing adds a domain for HTTP syntax highlighting. So when you install this, it actually includes a whole bunch of other extensions, some of which are for some of the most popular web frameworks. ODST is a Flask application, so I'm adding in my conf file here, there's our 3 original extensions. I'm now adding 3 more, the HTTP domain, and then auto HTTP Flask and auto HTTP Flask QRef. Now what those extensions do, the QRef extension will actually, if I point it to where in my code it creates that Flask app object, where once it's created the app object, all the routes are defined for the API, then it's actually going to auto-render those. So QRef Flask will create that small table of contents that we saw, and then auto Flask will render all the doc strings using that HTTP highlighting. So here is, which file is this? Oh yeah, this is the file for the admin API. So in here, for the docstring, for the about endpoint, at the top here, that little QRef directive, the first part of that is the category, because if you happen to see it in that table of contents, the endpoints were actually blocked together by categories. So this is the about category, and then that quick little stub description that was up there. And then down here for the source code directive, this is kind of like a code block, except it's for HTTP syntax highlighting. And then I'm detailing here the response to this is going to be a 200 OK. It's going to be application JSON for the content type, and then an example of a return in JSON. This renders, this does syntax highlighting on that JSON when it renders the docs. Go down a little bit further. Again, here's another one that's also in that about category, and this one is actually for updating settings for the server. And then this is an example of how to make a request, and it's kind of the same thing. It's a post. It's a post to /admin/API/about, content type application JSON, and then an example of what you would send. And then an example response where it's a 201 with no content. So right now, all I've described is a whole bunch of manual work, and your code is not actually documenting itself. I haven't lied to you. All this groundwork can be leveraged into making it so that your code can document itself. Quickest path to that is actually to use a service called Read the Docs. And readthedocs.org is a site for hosting documentation for your projects. And it works directly with GitHub. So if you go to readthedocs.org and you go and sign up for an account, you can then import your projects that you have on GitHub. And if they're set up with a docs directory and you can generate documentation using Sphinx with them, Read the Docs is built on all these tools. It will every time that you commit to the branches that you set up in here, it will actually trigger a build process for your docs. readthedocs.org will actually go out, pull in that branch that got committed. It'll run the build process for the docs, and if they succeed, it will update the documentation that's live for your project. So in this case, for ODST, I actually have two branches. Latest maps to the master branch, and develop maps to my develop branch. So it's, pre-release documentation is on my develop branch. So every time I commit to either of those, it shoots out a webhook to read the docs. Read the docs will then go back and clone the project, build the docs, and then put the latest version out here online. And there are some things that Read the Docs does that get slapped on top of what you saw before, where they were just locally loaded. There's this little menu that you can expand the lower left-hand corner to flip between the different versions of your documentation that you have available. And they also have the PDF and EPUB builders right there for people to click on to download a copy of it. So if you're working on a public project that's on GitHub and you've configured Sphinx, you can link it to readthedocs.org, and then as you commit your code, it is automatically building documentation for your users and other developers to consume easily. And it is, in effect, documenting itself as you're working on it. You're not jumping back and forth between systems. But if you're not using GitHub, or you don't want to have public docs, what are your options at that point? Well, you still have a couple. Who here uses anything like Jenkins or Bamboo or anything like that? So those are build processes. They link in to run build jobs. So if you trigger it, it'll read in your code and then perform some actions that you've defined. An option that you have is that you could hook up Jenkins or Bamboo or whatever build tool that you do happen to be using into your repo so that you can still get it where it triggers a job as you're committing code. So like at Jamf, we use Bitbucket internally. So so I don't have anything to hook it into for Read the Docs, but I can still have Bamboo react to commits on Bitbucket and then build all the documentation and have it available as an artifact that I can then deploy somewhere. You could roll your own documentation server by just having an Apache or Nginx server running somewhere where you just have the build job copy the documents onto that server every time it runs. Another option is that maybe if you wanted to take it a step further, you could just embed the documentation into the deployable project. So like for this example here, I actually added a documentation button into the menu bar for ODST. And what I did was the built HTML docs I copied into the project afterwards, and then they're just being referenced by this button. So this is an example where your other alternative is to just build the docs and deploy them with your project wherever it's going, so they're actually hosted in the same place. So if you want to know more, really everything I've shown you here is just straight off of Sphinx's documentation website. So the tutorial, I highly recommend that. The RestructureText primer is something I still go back to all the time because I don't remember all the directives that are available to me. Markup constructs, and then the more information about the domains, because it does support other languages like C and JavaScript out of the box, and then extensions are available for other languages. And besides that, does anyone have any questions about Sphinx and Python documentation? Was that smile a yes, Tom, or are you good?
No, I'm good.
All right. Cool. Well, thank you for coming.